Hello everyone. We'll discuss inductive thinking model. I think this topic was discussed in the classroom last year, but as one of the students requested me to again revise it, this is an attempt to make you all understand this particular model. As you all are aware, along with concept attainment model and inquiry training model, inductive thinking model is the third one, and it is considered to be one of the difficult models to understand, but we'll make an attempt to learn it in a simpler way. Okay, there are certain assumptions which are underlying this model. The first one is thinking can be taught. We all are aware that you can teach your students how to think. Thinking is an active transaction between the individual and the data. Now, in order to elaborate this, an illustration can be given. Say suppose an apple is kept in front of your eyes. Okay, there are various thoughts that will come to your mind about the apple. Since you have learned about apple, you have had experiences of apple. So whatever thoughts that are coming to your mind is nothing but an active transaction which is happening between you and that particular object, that is apple. So the same thing would happen with the data. So when you look at a data, you start thinking about it. There are various thoughts that will arise in your mind. Then the third point talks about thought process evolves in a sequential order that is lawful. As in, whenever you think, the thread of your thinking pattern would definitely be in a sequence, a logical sequence, which will start from basic to a complex one. Okay, this point you will understand as we progress through the presentation. Now moving on to the next slide, let us see the objectives of inductive thinking model. It will help the students in forming concepts. Now we all are aware what are concepts. They are nothing but an abstract understanding that we have about anything. So it will help you understand the concept, to nurture attention to logic. It will help the students understand why it is important to think logically, why it is important to have a reason behind whatever that you are saying or doing. To nurture sensitivity to language, as in order, like say suppose, since I'm thinking, it's very important for me to transact what I'm thinking to the other person. So how you say it or how you transact it to the other person is also very important. So it will help you understand the importance of the language. So this is the third point, that is to nurture sensitivity to language. And the fourth one is to generate awareness of the nature of knowledge. Now, when I talk about knowledge, knowledge is of different types. Okay, I'll not go in much detail of that. But yes, a person understands what kind of a knowledge he or she is dealing with, or what kind of a knowledge he or she is creating or developing. Now the next slide is about syntax. Now every model, as we had discussed about this earlier as well, have few stages. Okay, now this syntax has 3 stages which have been identified by Hilda, Taba, the one who proposed this model. Now each phase is built around a mental operation. Okay, now what is mental operation? Mental operation is nothing but your thought process, the way you think. First one is, the first mental operation is concept formation. Second one is interpretation of data. And the third one is application of principles or ideas. So in a general way, I can say it is a generalization, applying it to a lot of people, a population. Now to start with, okay, we'll see this as well. At each phase there are some overt activities. This is again very important. Overt activities, and these overt, sorry for the spelling mistake, it's not over, it's overt. So read it as overt, and these overt activities assume that there must be covert mental activities or operations a student must engage into performing the overt activities. As in, whenever I think something, okay, now there are 2 words here, overt and covert. What is overt? Overt is nothing but an activity which you perform or which can be seen. But covert activity is something which happens in your mind, basically thinking. So when you look at something or when you perform any activity, Okay, while you're performing that activity, there is something happening in your mind at the psychological level. So I'm talking about that aspect of the activity which we call covert activity. Okay, so in general, if we try and understand this, overt is nothing but which you can see outside. Okay, covert is something which is within, that is at psychological level. Now all these activities, really sorry, I don't know whether you are able to see this, but I'll read it for you. All these activities follow an orderly sequence and form the syntax of the model. So whatever activities that will happen, covert and overt, so both these activities will happen simultaneously while discussing this particular model. So all these activities are in sequence, as we discussed, as also we have seen it in the previous slide, that the thought processes, they occur in a sequential manner. So this is the sequence which I was talking about, and this forms the syntax of this particular model. Now to start with, there will be three phases. The first, as we have seen earlier, the three stages or phases you can call it. The first phase is concept formation. This includes three more stages. That the first one is data identification and enumeration. Second one is grouping data into categories. Third one is developing labels for the categories. Now we'll see in detail each of these three stages in the first phase, that is concept formation. Now let us just read this, okay? Do not get confused looking at this slide. Now let us simply read it. Look at the data on animals. Students create a data file. The next is decide which animals are most alike. Then students will group things that are listed. Now what would we call these groups? It's not B, it's V. And students will develop labels or categories. Okay, and there is one term that is given there, that is mental operations. So whatever that the students were doing, or whatever that we were doing indirectly while reading this particular content, are nothing but mental operations. So mental operations are nothing but the thought processes that are going on in our mind. Okay, just leave it here, and now just look at this table now. Here there are three columns. Okay, the first column talks about overt activity, which I have already told you all that overt is something which you can see. The next one is covert mental operation, is nothing but whatever that happens to you at the mental level or psychologically. And then the third column is eliciting questions. So what kind of a question will elicit? When you elicit, will develop what kind of mental operation at covert mental operation, or what kind of activity you need to do. Now the first one, in the previous slide, if you see, data identification, enumeration, grouping data into categories, and the third one is developing labels for the categories. Now look at this table. So the same stages or same 3 points are being placed in a row in the first column. If you look at the first row, it talks about enumeration and listing. And the covert mental operation which is given here is differentiation or identifying separate items. And eliciting question is what did you see, note or hear. Now to take an example, say suppose if a data is presented to students. Now if I take an example of the common one that we do usually is I present to the students different animals. Okay, different animals. I will not disclose what kind of animals or what classification I am talking about. So pictures of different animals are given to the students or presented to the class. Okay. Now in such a case, in this situation, what is the first stage or what will happen in the phase 1, that is concept formation phase, to the students in an overt manner and a covert manner is what we will see now. Now enumeration and listing. So when you will apply this model in the classroom, the first thing that you need to tell the students to do is to differentiate or separate the items based on whatever criteria they think is applicable to the given data. Now some students will classify them as carnivores or herbivores and omnivores. Some will classify them as domestic and wild animals. Some will classify them on the basis of the animals which they like and don't like. Likewise, various categories or criteria they might choose to differentiate. Okay, so the first thing that they will do is differentiate or list. Okay, now after they differentiate or after they list or enumerate, the second thing is grouping. Now here they have to identify commonalities or properties among data items. Now here in the first category wherein we talked about differentiation or enumeration, here they were doing it at mental level. They are trying to find out how different they are and what way they can categorize it. But in the second stage, that is grouping, they are actually grouping them. And while grouping them, they are focusing more on the criteria or the commonalities which will help them differentiate them properly. Because even if they are talking about domestic and wild animals, even while doing that particular overt activity, there will be one or two animals which they will be confused about, or about whom they won't have proper information. So in order to do grouping, it is very important that they know the properties that belong to that particular animal or whatever information that they possess about that particular animal. Now labeling, that's the third part of the first phase. That is labeling, that is determining the hierarchical order of items, super subordination. What would you call these groups, or what belongs this to this category? Now here you are labeling them, as in, although I have labeled them in the first stage, but this is, since it is a hierarchical order or since it is a sequential order, first thing is you just at mental level understand how these animals can be grouped, or what are the ways by which I can think of grouping them. Second, in the second category, you actually group them into two categories wherein you separate both the separate the items. Need not be always two categories, it can be three as well or more. Labeling, now you are labeling the category or the group that you have made. So suppose if I have collected 10 out of 20, 10 are placed in one group and 10 are in the other. What would you call a group of 10? Would you label them as wild, domestic, carnivores, omnivores, herbivores, or the animals which you like or don't like, likewise? Okay, so please understand this, that overt activity, covert mental operation, eliciting questions. Now each activity is linked to one covert mental operation. This is something that you do physically, and this is something that you do at psychological level or at mental level. Now the first phase of this particular syntax is over, that is concept formation. So here if I go back and look at this particular phase, that is concept formation, here the students have developed a concept, they have developed an abstract understanding about that topic or about the data that is presented to them, that this particular data which is presented to me by the teacher is of animals which are divided into three categories or two categories. Okay, this is their understanding. It need not be always correct. They need not judge them. Neither the teacher needs to do. They have to just do it as they wish. Say suppose if you are doing this activity by dividing the students into groups. If 10 groups are there in a class, it is perfectly alright if all the 10 groups have their own categories, because not every person or every group will think in the same way. So the idea behind this particular activity is to get various ways by which the data can be grouped. Okay, so each group have formed their own concept. One group might have formed a concept of carnivore, omnivore and herbivore. The other group might have formed a concept of the animals which you like and don't like, and the third group might have formed a concept of wild or domestic animals likewise. Okay, now moving on to the next phase, that is interpretation of data. This phase is built around three mental operations, like how we had three there, enumeration, grouping, and the third one was labeling. Likewise, we have three mental operations here, that is interpreting, inferring and generalizing. Now what do we do here in the first phase? Now the students build hypothesis about relationships, inferring causations, explore this hypothesis to build generalization. So this is a summary kind of an explanation of this particular phase. In detail, let us see it in this table. Now the first one is identifying critical relationships. Okay. Now interpreting. Now why am I calling this particular first overt activity as interpreting is identifying critical relationships. Covert mental operation here is differentiating. What did you notice or you find? Now when they have grouped already the information into already the data that is presented to them into categories wherein they have formed their own concept, here they are identifying a critical relationship or differentiating. Now when I talk about wild animals, I am critically thinking why they are called wild. So basically I am talking about the characteristics of that particular category, why these animals are called wild. I need to know why they are called wild, or why they are differentiated as domestic, why some of these animals are called omnivores, why some of these animals are called herbivores, and why the other category is called carnivores. Okay, so here I am identifying a critical relationship between the groups. Okay. Now the second one is exploring relationship. Now if you look at inferring, here relating categories to each other, determining cause and effect relationship. Why did this happen? Now if you look at this particular, this is like how we had in the previous table, where in the first stage what did the students do? They have just done it at mental level. Similarly the same thing would happen here. Now here they are identifying the relationship at mental level, differentiating. What did you see, what did you notice or find? Okay, so this is at mental level, at discussion level with the peers. Now exploring relationship, here they are relating, as in they have to write down the characteristics of each category, why they are called. Like if I have grouped 10 animals in a category, I will write points why these are called wild animals. So I will write because they live in forest, they are not domesticated or something like that. Okay, so I will write few characteristics of first category and few characteristics of the other, by which I am relating both the categories. Okay. Now the third one is making inferences, going beyond what is given, finding implications or extrapolating. What does this mean? What picture does it create in your mind? What would you conclude? Now here the important stage is making an inference. Now you are basically inferring it in a way wherein now the categories are made of the animals, that is herbivore, carnivore and omnivores. Now beyond what is given, is there anything that you can think? Now the concept that I have formed is of carnivore, omnivores and herbivores. Is there anything that I can go beyond and infer about it? Now why do you think that the teacher has presented this to us, or why do you think why it is important to know this? I'm extrapolating, like maybe another concept you can add to the existing one. Now say suppose if the teacher is about to teach us about different types of animals, or if the teacher is planning or preparing us in order to make us learn more about wild animals, or maybe flora and fauna that is existing, or some topic which is related to that particular area. Okay, so here the students will generally infer or extrapolate, or maybe write something extra which is not given in the data, or which is not presented in the data. Now the third part is application of principles. In this phase, students apply generalizations arrived at in the second phase to explain new phenomena. Now, as we have seen in the previous table, that is interpretation of data, making inferences. Making inferences is nothing but coming to conclusion, as in coming to a summary of the overall process that they have gone through. So here they are basically talking about how these inferences can be generalized, or how they can be generalized or applied. Okay. Now here the overt activity which is given in the first row is predicting consequences explaining unfamiliar phenomena of hypothesizing. That's what we were discussing, that they think about something beyond what is given. They frame hypotheses, they come up with assumptions, they predict consequences. What if wild animals are dead? What if we stop domesticating animals? What if we kill all the herbivores? What will happen if all the carnivores are extinct? They undergo extinction. What will happen if no omnivores are found? What will happen to the food chain? What will happen to the food web? Okay. Likewise, so analyzing the nature of the problem or situation, as you can read in the covert mental operation, retrieving relevant knowledge. So I'm relating it to something relevant to the topic. As in, a teacher here is not introducing them, but yes, they are trying to find links of this topic to anything that can relate to them. Like, what would happen if? This is a question. Now, explaining and supporting the predictions and hypotheses. Here they are determining the causal links leading to prediction hypothesis. The question which is asked here is, why do you think this would happen? So here they are not only making hypothesis, or they are not making predictions just like that, but they are supporting their predictions with an explanation, or they are supporting their prediction with something that has happened earlier. Okay, if there was any change in the food web that has affected the environment, if there was any change in the food chain that has caused any impact to the environment. Okay, so they support their conclusion, or they support their hypothesis. They cannot just say anything in the air. Okay, if I'm relating it to food web, yes, they need something that will support that. Yes, this particular topic has something to do with the food web or the food chain. Now, verifying the predictions. Now, here they have made hypotheses, or they have made assumptions. Now they have to verify if whatever that they are relating or collating, or whatever that they are trying to link, has any relation in actual or not. Now, using logical principles of factual knowledge, which I am talking about, to determine necessary and sufficient conditions. What would it take for this to be generally true or probably true? Whether this makes sense, whether these links that we have made make sense, or whether it can be generalized, whether it can have any consequence later, whether it is actually related to each other or not, is what it is done in the third row, that is verifying the predictions. So if you look at all these three phases, in the first phase wherein we discussed about how the concept is formed, wherein they enumerate, wherein they group, and wherein they label the categories, and in the second stage which is about interpretation of data, wherein they interpret what can be the relationship at the mental level, then they infer, as in what can be the relationship at general level, as in they summarize it there, wherein if we look at this particular phase, that is interpretation of data, inferring, if this table, they relate the categories, isn't it? Now they make inferences, so summarize, that's what I was talking about, going beyond what is given. And a third phase, they generalize, so whatever conclusion they have come up with, they relate it to something new, or they try and extrapolate it and explain new phenomena. Say suppose, if the same example I take, types of animals, herbivores, omnivores and carnivores. This is a general topic. In the first stage they have labeled them, grouped them. Okay, now in the second stage they have interpreted them, why it is so, what is the characteristic of each group, how they are related to each other, and they infer, or they summarize. Yes, this is the overall understanding of this particular topic. And now that understanding, they are trying to link that understanding to a new topic like food web or food chain, and they are trying to make sense. They are hypothesizing in the first stage, then they are collecting materials which will support their hypothesis, and again in the end they verify whatever predictions or whatever information that they have created, or the knowledge that they have created out of this processes. Okay, so this was about the three phases. And social system, as we have seen earlier, is it atmosphere of the classroom, basically what happens, what is the situation that you see in the classroom, that the atmosphere needs to be cooperative because they are working in groups. Teacher determines the sequence of the activities in advance. That's what I'm saying. You need to guide them what is the next step they need to do, because this is something scientific, this is something logical, and this needs to happen in a sequence. So it's very important that you tell them what next. Now, initial phases, teacher control the activities wherein you give them the data and everything. But later, you just need to hint them, yes, this is what you need to do. Now, link them. How you write the characteristics, or write characteristics of both these groups, and now infer. Only this commands or this instructions the teacher needs to give. Later on, as the students learn the strategies, they assume greater control. So, afterwards, as they understand how to go about it, or how to go about the model or strategy, they understand it in a better way and they can manage on their own. Now, teacher keeps a track of the data inference is done. So you need to know what each group is doing. If whether the first stage of concept formation is correct or not, whether they are going in the right direction or not, or if they are not going in the right direction, you need to guide them. Now, students enumerate, list, group, and label the data. They try to identify critical relationships and draw inferences. Students later also have to predict consequences, explain unfamiliar data, and support their explanation, isn't it? This is what we discussed in the last table. They also have to verify these predictions. Now, principles of reaction, how you need to behave or how you need to interact with the students. Teachers should take care while using the cognitive task within each phase, such that these tasks occur in optimum order and also at the right time. She should regulate or he should regulate the task in such a way that during the phase, one student should not be allowed to proceed with categorization until and unless they are thorough with the data set. That is, they need to understand the kind of data that is given and should not go for classification of data without understanding what is given at first. So also the students should be made to look at the relationships within and between the categories only after categorization is complete. I hope you are able to link this to what we discussed earlier. So it's important that they understand the relationship within the group and also between the groups. She or he should monitor how students are processing the information and then use appropriate eliciting questions. So the teacher should be aware what each group is doing and how they are going about, whether they are on the right track or not. One important task of the teacher is to sense the students' readiness for new experience, whether they are at a point wherein they are able to extrapolate the information that is given to them, whether they are able to relate that particular information to a new concept. Now, support system here can be the data or the raw data that you are providing. You can help them with audio visuals. You can a resourceful teacher definitely is one of the support system, because you need to know what you are doing first. You should be very clear about the concept. Then only you can give them examples to help them out. If you yourself are confused, then things can get difficult. Now, application, it can be used in every curricular area. You can make, you need to choose a topic though, which will be suitable. It can be used at any stage of education. It can be used to increase, can be used from kindergarten to high school. As in from kindergarten to high school, at any level you can make use of it, because the students, because this is something which is basic, okay, classification and all that. So it's very important that you understand the level at which you are dealing with. It can be used to increase creative thinking. So here students are indulged into creative thinking because students are thinking something new or creating something new or linking the old information to a new concept which they were never aware of. Or it can be used to help students collect information, organize it into concepts, and to learn to manipulate this concept. So basically, as we have seen here, that data is given, so they collect information from the data, then they form concepts, they organize the concepts, and they manipulate the concept at the end by linking it to a new one. It helps the students to use concepts efficiently. Okay, so they learn the concept properly and make use of it. It helps the students in developing multiple perspectives from which they can view the information. So in a group, even if 2 or 4 members are there, everybody in the group, in a single group, would think differently. So they understand that the given data or the raw data can be viewed with different perspectives. So it helps them understand that as well. The student can learn to categorize. So there will be various categories in which criteria by which the students will think. So they will learn how to categorize. Now the last part is instructional and nurturant effects. Instructional effects are nothing but those effects, or we can call them direct effects, which you can see or observe in the classroom. Okay, by using this model, these are the instructional effects which you can see that is instruct students in concept formation process, teach specific concepts, and nurturing effects are attention to logic, sensitivity to language, and awareness of the nature of knowledge. So this would be same as that of the few points that we discussed at the beginning of this slide. Okay, here the students learn to form the concept. Okay, it helps the teacher to teach specific concepts. So this is an effect, an instructional effect, a benefit to the teacher. And nurturant effects are indirect effects, which these are the effects which are not seen visibly, but yes, these are the changes which happen in a student or a child who is going through this model. That is, they understand that logic is important because they have to categorize, write characteristics, group, they have to assume, they have to support the answer. All these things require logical thinking. Sensitivity to language, wherein they need to explain or express their view or their perspective to the other person in the group or to the teacher. And awareness of the nature of knowledge. What kind of a knowledge? This point, as I told you in the beginning, that we will discuss later. Awareness of the nature of knowledge. What kind of a knowledge they have created at the end of this process? That, as we discussed, that omnivores, herbivores, and carnivores, they have linked it to food web or food chain. What kind of a knowledge it is? Whether it is the right knowledge, or whether it is verifiable, whether it is proven, what kind of a knowledge they have created is also very important. So this is an understanding or indirect effects which you can see from this model. Okay, so this was about this was about inductive thinking model. If you have any questions related to this, you can please comment in the comment box below and ask the queries. If you have any confusion, this topic is a bit difficult to understand, but yes, you can attempt understanding it by relating or making connections of each step or each phase with an example, okay, which will help you understand this topic in a better way. Okay, I hope that this presentation or this explanation was helpful for you. So thank you very much everyone for your patient listening.